So what I want to do with you guys today is to review with you how to solve trig equations, okay? So this first example is I want to solve 2 sine x minus 1 equals 0 for 0 less than or equal to x less than 2 pi. So this is one rotation, right? So our angle is going to be positive. Our angles have to be between 0 and 2 pi, all right? So this is basically the domain of it, okay? All right, so the very first thing you want to do on all of these is we want to isolate the trig function. So we want to get the sine x by itself. So I'm going to want to add 1 to both sides. So that would give me 2 sine of x is equal to 1. And then I'd want to, because I'm multiplying the sine x by 2, I want to divide both sides by 2. And that would give me sine of x is equal to 1/2. Okay? Now, before I go on, let me get another colored pen. All right. What I want to tell you is you got to remember what these are. Okay. So this is a ratio of x, y, or r. So for sine, the definition is this one is my y and this is my r. So because this ratio is positive, what determines whether this ratio is positive or negative if it's sine is this y. So we know y is positive. So that means, okay, there's only two places this could be. Well, y is only positive in these two quadrants. So one of our answers isn't going to be in this first quadrant, because in this first quadrant, this y would be 1 and our r would be 2, okay? It's also this y would be 1 and r would be 2 in this quadrant, okay? So this is my y. Sorry, I should not have put -1. Here I said it. And then I wrote -1. So y would be 1 and r would be 2, okay? Now, where these are located, we should recognize, oh, this side right here would have to be the square root of 3. And this right here would have to be negative square root of 3. Now, it's square root of 3, but it's negative because we're going left, okay? Now, what are my reference angle? Well, this is a 30, 60, 90 right triangle. And I know that opposite this one is always pi over 6. So this is pi over 6. And this angle of the triangle would also have to be pi over 6. And then what's my angle that I would have to rotate to get here? So I'd have to rotate to here and also continue going to right here. Okay. Now recall that this angle from here all the way to here is pi. In this case, because our denominator is 6, I'm going to call it 6 pi over 6. All right. So what's the angle that I would have to rotate? In other words, what's this x value? Well, x would have to be equal to exactly pi over 6. Or if I rotate all the way here is 6 pi over 6, I got to back up a little bit, right? How much do I have to back up? I have to back up a pi over 6. So that would make this angle from here to here 5 pi over 6. So 5 pi over 6. Okay? And that's how you solve a very basic trig equation, okay? All right, and we know how, not more complicated ones, there's other complicated ones, but we need to know how to solve these really basic ones. Okay, again for this one, we want to solve 2 cosine x plus the square root of 2 is equal to 0. Again, x is between 0 and 2 pi. Okay, so I want to get cosine x by itself. So I'm going to need to subtract square root of 2 from both sides. So that'd be 2 cosine of x is equal to negative square root of 2. And then again, I need to divide both sides. So that'd be cosine of x is equal to negative square root of 2 over 2. Now, we should recognize that because we've seen it enough, okay? This is square root of 2 over 2 is actually 1 over the square root of 2. So I'm going to rewrite this as cosine of x is equal to negative 1 over the square root of 2, okay? So now cosine, the cosine ratio is x over r. This is my r, this is my x, and I know my x is negative. Okay, so what that means is since I know this is x and it's negative, right? This is, I should say this again. This is x and this would be r. Okay, I know my x would have to be -1, so it's in these two quadrants. This ratio has to happen in one of these two quadrants. So I'm going to go and draw. This would be -1, and I'm going to draw here and then also down here. So my two triangles are in these. Remember, this is the point that we're looking at, and we always want to draw the vertical leg to the x-axis. We don't want to draw it to the horizontal or to the y-axis, okay? We want to draw it to the x-axis. Okay, so I know this x is -1, and then I know this would have to be the square root of 2, and this would also have to be the square root of 2. This side right here, we should recognize, oh, this one's going to be +1 because we're going up. But this one over here would be -1. That's our y, okay? And then what's the angle of the triangle? Well, the angle of the triangle right here would be pi over 4. And this is pi over 4. Okay, so I'm doing pi over 4. So that means this right here is pi, but I'm going to write it as 4 pi over 4. So what's this first rotation? To here, and then also all the way to right here, okay? So my x here would have to be, okay, so to right here, going all the way to 4 pi over 4 is too much rotation for the first angle. I'd have to back up a pi over 4. If I take a pi over 4 away from 4 pi over 4, that would give me 3 pi over 4. So that's one of my answers. The other answer, I'd have to keep going past this 4 pi over 4, one more pi over 4, and that would put me at 5 pi over 4. And there's my two answers for that problem. So for this next problem, we want to solve sine of x is equal to 0. Now, 0 is not a ratio, or is it, right? It could be written as a ratio because you could write 0 as 0 over 1. And 1's the simplest one to use. You could actually use any number, but it'd be easier to use that, to just use 1 for a denominator, okay? So I'm going to write this as sine of x is equal to 0 over 1, right? Okay. Now, where could this happen? Where could this ratio be 0? Now, there's another time where this could happen. It could also be 0 over -1 because 0 over -1 is also 0, okay? So remember, again, for sine, this is my y and this is my r, okay? So that means my y would have to be 0. Well, where would y be 0? Okay, well, y is only 0 on the x-axis. So it could happen right here, all right? And it could also happen over here. So right here, my x would be 1. If my r is 1, my x would have to be 1 in this case. My y would have to be 0, and my r would have to be 1. Over here, my x would be -1. My y would still be 0, and my r would equal 1. So there's two angles here, right? It's this angle right here or this angle. So what's this angle right here? Well, that's angle 0, okay? So my answer to this would be x is equal to 0, or if I rotate to here, that is a half rotation, so that would be pi. Now, some of you might ask, well, why don't you just go all the way around and call this angle 2 pi? Well, right here it says we can't include 2 pi. We can include 0, but we can't include 2 pi, okay? And that's the reason why. Okay, for this next problem, we want to solve 3 tan squared x minus 1, okay? So remember this tan squared x means tan x times tan x, right? Okay, so we want to, again, we want to get tan squared x by itself and then get tan x by itself. So I want to add 1 to both sides. So this would give me 3 tan squared x is equal to 1, and then divide both sides by 3, and that would give me tan squared x is equal to 1/3, okay? And then to undo a square, we're going to need to square root, okay? So I'm going to square root both sides. Now, remember when we square root a perfect square like this, it's actually the absolute value. That's going to be important in future lessons, okay? This is the absolute value. So we can swap this out with absolute value. So this is the absolute value of just simply tan x is equal to, and we need to recall that this square root is actually an exponent, so it goes with the numerator and denominator. So this is the square root of 1 over the square root of 3, which would be 1 over the square root of 3. Now, what could this in here be to get a positive 1 over the square root of 3? Because remember, absolute value is distance. So this tan x could either be 1 over the square root of 3, or tan x could equal negative 1 over the square root of 3. Okay? Now, recall, basic definition. Tangent is y over x. So this is my y, and this is my x. This is my y, and this is my x. So I'm actually going to have to draw 2 diagrams. One where this ratio is positive, because to make this ratio positive, either both of these are positive or both of them are negative, okay? So if we have 1 over the square root of 3, right? This is the diagram for tan x is equal to 1 over the square root of 3. That could happen right here, where both y and x are the square root of 3, okay? And it could also happen here. Now, they're not positive, right? But the combination of these two, if they're both negative, because in this quadrant, the x and y are both negative, when you do that ratio, it's going to wind up being positive, okay? So in this case, my y would be negative 1, and my x would be negative square root of 3. That makes this hypotenuse 2, this hypotenuse or radius 2. That would make the angle be opposite this one is always pi over 6. And this one is pi over 6. Okay, and remember this is angle 0, and because we're in 6, I would call this one 6 pi over 6. So my answers for when it's positive 1 over the square root of 3 would be x is equal to, and it would be pi over 6. And then this would be 6 pi over 6, and I would need to rotate 1 more pi over 6. So that would be 7 pi over 6. Okay, where tan x is equal to negative 1 over the square root of 3. Well, that can happen when either the x or the y are opposite signs. So where does that happen? Well, that could happen right here in this quadrant, right? Because my x is negative, but my y is positive in this quadrant. Okay, so what did I say just a minute ago? My y is going to be 1, and my x is going to be negative square root of 3. That would make this 2. Where else could this happen? Well, it can't happen here because both the x and the y would both be negative, right? So that would make this ratio be positive. Well, it could happen right here because right here, my x is positive, but my y is negative. So one of them has to be negative. Okay, so in this case, my y would be negative 1 and my r would be positive square root of 3. The relationship between these two legs, this hypotenuse or radius, would have to be 2. That would make the angle of the triangle here, again, pi over 6, and this angle pi over 6. Now remember, this would be 6 pi over 6, which is just pi. This one over here would be 12 pi over 6, or 2 pi, right? So if I rotate all the way to right here, going all the way to 6 pi over 6, I'd have to back up, right? A pi over 6. So this would be 5 pi over 6. So that's a third answer to this problem, okay? Right here, so that would be this rotation right here. If I keep going all the way to this one, right? Well, if I went all the way to 12 pi over 6, to get this angle of rotation, I'd have to back off a pi over 6. So that would be 11 pi over 6. And that's my fourth answer to this. So there's actually 4 answers to this. Pi over 6, 7 pi over 6, 5 pi over 6, and 11 pi over 6. And you could put these in a different order. The order and how I wrote these doesn't matter, okay? All 4 of them are answers, okay? All right. You know, I should say this. On Delta Math, to type multiple answers, you can type a comma, and then it pops up a little box where you could type the next answer. And if there's like 4 of them, you would just keep putting commas like I did right here. It's just like how we write it. Okay. So I should point that out on Delta Math. All right. One more problem. So for this last problem, we want to solve secant x plus 1 is equal to 0. So once again, get that trig function all by itself, right? So I'm going to subtract 1 from both sides, and that would give me secant x is equal to negative 1. Now, that's not a ratio, but it could be written as a ratio because we could imagine there's a 1 underneath this. So secant x is equal to -1/1. Now, remember, secant is the reciprocal of cosine, and cosine is x over r, so this ratio has to be r over x. So this one has to be my x, right? The bottom has to be my x. Now, remember, r is never negative, right? So this is +1 and this is -1. So really, it's secant x. The only way for this to happen is our r is 1 and our x is -1. So our radius is 1 and our x is -1. So where could that happen? Okay. Where would x be 1 or -1 and r be 1? Well, it would only happen right here. Okay. Why? Because right here, my x is 1, right? But my x has to be -1, right? So it's here or here, but the only way for the r, the radius, and the x coordinate to be the same is if it's right here and it doesn't form a triangle at all. It's just right on the negative x-axis. So right here, my x is -1, my y is 0, and my r is equal to 1. Okay, so what's this angle that I would have to rotate, right? I'd have to rotate all the way to here. And for this one problem, there's only one answer, and it's that angle right there. That's it. That's the only place, because there's no other place where x would be -1 and r would be 1, okay? So that means this angle that we'd have to rotate is just simply pi. So the answer to this is pi. All right? And that's it. So I want you to solve some trig equations today, okay, for your homework.